Hi Math 142 class. This video is a brief explanation of the section 5.1 notes, which are posted now in Canvas files. So let's go ahead and pull those up now. In Canvas, on the Files tab, Lecture Notes Completed. And Notes 5.1 filled. In this video, I'm going to go through the completed notes and make some comments and point out some important things. Remember, in Exam 1, you already had one identity proof. Well, Chapter 5 will be a continuation of what we've already done on proofs. So far, the basic identities that we've learned and that you memorized for the memory quiz are the reciprocal, the ratio, and the Pythagorean identities. You're going to need to refresh your memory on these, review them, because you're going to need them for the Chapter 5 proofs. Especially review the 1 plus tangent squared and 1 plus cotangent squared identities, because those are the ones you probably have forgotten. Just like in the proofs we've already done, you're going to need to use a two-column proof where you have the statements on the left and the reasons on the right. The first step should be to copy one side of the identity, and your reason, the first reason should always be copy the left side or copy the right side. Then put one step on each line with an explanation beside it of what you just did. For example, on the proof here in example 1a, the second reason is the ratio ID because that's how we got from step 1 to step 2. So the reason explains what just happened from the previous step to this step, not what's going to happen next. So for example, on part B, in step 2, you can see that cosine theta is lightly crossed out, but cancel is not the reason on step 2. You see the reason cancel in step 3 because this canceling is how we got from step 2 to step 3. That's where you see the reason there then on step 3. Let's scroll to example 3. Here's an example where all the skills you've reviewed on the factoring worksheets are going to come in handy because sine to the fourth theta minus cosine to the fourth theta is a difference of squares. So factoring is going to be part of your proof. And when you factor this difference of squares, one of the factors is sine squared theta plus cosine squared theta, which equals 1. But then what? If you take a look at where we're at here, what do I do next? If you're stuck and it's not clear what to happen next, sneak a look back at where you're trying to go. So look at what we have here is one fraction. Where am I trying to go? Two different terms separated by a subtraction sign. So that's what would give me the idea here to separate this fraction into two separate ones so that I can try to get to where I'm at up here. And if we continue here, we can reduce each of these individual fractions and use the reciprocal ID to finish the proof. Example 4 shows a new technique for proofs that we haven't used yet, I don't think. It uses the idea that's like a conjugate from algebra. Here in example 4, we have cosine squared theta over 1 plus sine theta. And the steps shown here use the idea of a conjugate to multiply the numerator and denominator of the conjugate of 1 plus sine theta, which is 1 minus sine theta. When we multiply and get 1 minus sine squared theta, that allows us to use the Pythagorean identity to change 1 minus sine squared into cosine squared and then cancel it. Actually, on this particular example, we didn't really need to use this technique. It would have been probably easier to simply change the cosine squared theta using the Pythagorean identity, change that into 1 minus sine squared theta. So I'm suggesting using a version here of the Pythagorean identity where we've subtracted sine squared from both sides. Cosine squared theta is 1 minus sine squared theta. And then we would have been able to factor and cancel. But the reason we showed this method in the notes is just to show this new technique of proofs, because in this case we had a choice, but sometimes we won't. So let's scroll to example 7, which is an example where you need this technique and there's really, I don't know of another choice. So in this example, we're proving this identity. And on one side we have cotangent b over cosecant b plus 1. So whenever you see something like that, that seems to be indicative of one of the Pythagorean identities, so something from these Pythagorean identities, except you won't see the squares in the technique that we're using, you'll see like 1 plus sine theta, or cosine theta minus 1, or cosecant theta plus 1, and so on. And if you use a conjugate of any of those, it's going to lead you back to one of these Pythagorean identities once you multiply. So when we multiply here on example 7, the conjugate of cosecant b plus 1 is cosecant b minus 1. You multiply numerator and denominator by that conjugate. When you multiply out the denominator, you get cosecant squared b minus 1. That leads us back to the Pythagorean identity. Here's the actual Pythagorean identity. And so if you subtract 1 from both sides of it, you get cosecant squared b minus 1 would equal cotangent squared b. Finally, example 8 shows the idea of a counterexample. Because to show an identity is true, we have to prove it step by step to show that it's true for all cases. But to show that a so-called identity is false, all that we need is one specific example of a value where it's false. And that idea is shown here in example 8. I wanted to remind you about another resource you have available to you, especially now during remote instruction. I recommend the textbook videos. So in your WebAssign account, if you go to our course and click My eBooks and go into the textbook, each section in the textbook begins with a short lecture video from the author of your textbook. So right now we're in chapter 5. Use the menu to pick the section you want. We want section 5.1, and he has a video here of some of the proofs. Now in this particular case, section 5.1, I'm concerned that he does not show reasons for his proofs, and I am requiring you to do that, so be aware you do have to write the reasons. But in general, these videos will be an excellent supplement, especially now while we're in remote learning mode. In Canvas, your homework handout is posted. Homework handout's blank, section 5.1. And actually this time you won't even need to print the handout because I've given you 10 proofs that I've actually asked you to use separate sheets of paper anyway. So you can just pull up the handout, do these proofs on separate paper. Be sure you're doing a 2-column proof with the statement and the reason, and then scan and upload your work into Canvas as always. The complete solutions are already posted in Canvas, so if you go to the homework handout solutions, the full solutions are posted for this handout. But once again, as always, use them wisely. Don't use them as a crutch. Try more than once to figure out the proofs before you pull up the solutions to check. Okay, so thank you for watching this video, and bye-bye for now.